Hello everyone, this is the second episode of this masterclass dedicated to the configuration, calibration, pricing, and risk of European equity options. And if you have watched the first episode of this series, which you should, you know that it comes with a free-to-download Excel spreadsheet and pre-configured examples ready to be run in open source risk engine, ORE. It is a relatively short video today, as we take a look at the trade configuration specifically for ORE, even though any booking system will offer similar features. In Chapter 1, we look at the basic parameters of an equity option, the trade parameters that you are most likely familiar with, and which we already tackled in an older video about equity options. But in Chapter 2, we look at special cases like Quanto, Quampo, payment delays, and other special nodes available in ORE. So let's take a look. Today, we will only talk about the NPV tab, which is where we calculate the price of a single European equity option, also with a few risk measures. But in this tab, we also calculate a standard implied volatility surface, call and put surfaces, and even an implied volatility surface, with one axis being the deltas. So to create an equity option instrument to use with ORE, we have to configure it in an XML file, with the main node being the portfolio, as you hopefully know already. We create a trade with whatever reference ID you want, with trade type being equity option, and the equity option data node. In the most simple cases, we need 5 nodes. First, the underlying reference or name. That's usually a Reuters or a Bloomberg ticket with the name of the equity stock. Then we have the payment currency of the option. Then we have the strike, obviously, and then the quantity. Now, in some cases, this number is itemized by splitting it into 2 variables, number of contracts and the contract size or the multiplier. And that's because on the market, given the amount, main actors tend to buy options by lots of hundreds or thousand. And while we are talking about this, the notional of a trade on options is calculating by multiplying the quantity of options, so here that's Q or N times M, by the agreed strike price. And you can see the corresponding variables here with the underlying name, the currency name, the quantity and the strike. Now, this is not really used in the calculation. However, quantity and strike are. Then we have the option data, which contains the optionality parameters of the trade and which has a few subnodes. First, we have the side of the trade, whether it's long or short. Then we have the option type, whether it's call or a put. Then the exercise style. For equity options, we are only allowing for European and American, but we're not looking at the American case today, so it has to be European. And then we have the exercise date of the trade, which needs to be a subnode of the exercise dates with an S. And here we represented it as the maturity date. One note that I forgot to include until now, and hopefully you may have seen the warning sign, which was displayed earlier, it's the settlement node. And it is mandatory in order to build the equity option in ORE. It can either be cash or physical. Cash meaning you receive the difference between the stock price and the strike. And physical means you receive the underlying stock as a physical asset, obviously. And we will be talking about it a little bit more in Chapter 2 when talking about the payment delays and settlement types. So this is the sort of basic way of building an equity options, but there are additional nodes which can be used. First of all, there's the underlying node, which can replace the name node, as you can see here. Now, for single names or index trades, like in our case, it doesn't really provide any additional features except in terms of verbosity, where instead of a concatenated identifier, you can now add more informations, and the concatenation will happen in the background. You can see here a few different identifier types for equities. You have the RIC for Refinitiv or Reuters, you have the ISIN, you have the FIGI for Financial Instrument Global ID, and you have the Bloomberg ID. And this node can be used for equity, like we just seen. It can be used for FX, commodity, interest rate, inflation, credit and bond. And you can provide weights similarly to basket node, including negative weights when you have a short positions. And there are quite a few other fields, especially for commodities contract, which usually require more information, as you can see here. Regarding the currency of the underlying, which is relevant for the next point I'm going to talk about in a few seconds, in ORE, except when the identifier is ISIN, which is a special case, it is not set up in the trade, but in the equity curve node related to the underlying in a curve config file, as you can see here. A second additional functionality I wanted to talk about is the Quanto or Compo case. As a reminder, a Quanto trade is when the payoff currency is different than the currency of the underlying. So it's when, for example, the currency in the trade, so this one, is different than the currency node in the curve config. So if you have Euro here and you have USD here, that's a Quanto case. A compo trade or composite trade is when the currency of the strike is different than the currency of the underlying. So if you have Euro here and USD here, this is a combo. And so you can achieve this, as you can see, with the strike currency node. And it's worth pointing out that in both cases, so for compo, like we just said, but also for quantos, the strike currency node is mandatory, even though in the Quanto case, the strike currency must be the same as the underlying currency. One thing about the spreadsheet, it doesn't allow for Quanto or Compo yet. And same as for the name node, there's an alternative with the strike data node, where instead of the strike and the strike currency node, we can replace it by this type of node. And with this particular type, and it's worth pointing out that you also have the possibility, obviously for different type of trades, to express the strike as a yield and to set up the compounding type. Another case, another node. This time we want to look at payment delays. So when the payment date is after the expiry or strike date. In a, let's say, standard option, the payment date falls on the same day as the expiry date. In that case, physical delivery or cash delivery, there's no difference in terms of NPV or any other risk measures. In both cases, you get something which has a value of stock price at maturity minus the strike for a call, or strike minus spot for a put. In both cases, we use the analytical European engine. Now, let's look at the case where the payment date is after the expiry date. When we have a cash settlement, and when the option is new money, of course, you receive the difference between the stock price and the strike, but at a later date. So in order to account for this delay, we can simply adjust the value of the option by a coefficient representing effectively the discount factor between the expiry date and the payment date, which we calculated by simply doing this. And if you're interested in looking at the C++ code, please note that in that particular case, we use a different engine called Analytical Cash Settle European Engine. And you can see here they are found in two different files. For the physical settlement type with delayed payment, I don't think our engine allows for this specific case because we calculate it exactly the same way as if there was no payment delay. Most likely we have not implemented this case because it doesn't really happen in practice. In order to build these 4 different cases in ORE, it's very simple. Case number 1, it's the sort of almost default mode. Cash settlement, no delay. That's the one we've seen so far. There's no changes. Case number 2, physical settlement, no delay. The only change is here, where you put a settlement to physical. Case number 3, cash payment, but payment delay. So it's built this way with a payment data node, dates, and then the date of the payment. And then case number 4, physical settlement with payment delay. If we price it in ORE, so we're just going to run this command, it's very quick. and then we're going to look at the output NPV, you can see that the only difference is coming from case number 3 as expected. There is an additional special case to consider when there is a payment lag, and it happens when the valuation date is on the same date or after the expiry date, but before the payment date. And you have 3 different ways to account for this in ORE. You can set up the automatic exercise to true or false. When set to true, the option is exercise normally, if it's in the money, of course. When it's set to false, which is the default case, by the way, the option is not exercise, so its value is equal to 0. And there's a third way where instead of using the automatic exercise node, you provide explicitly the underlying price at the expiry date. And the payoff becomes the same as when the automatic exercise is set to true. Now, if we look at how it's done in ORE, on the left here, we have the trade that we've seen earlier with case number 3, settlement cash and payment delay. Now here, in order to illustrate this special case, we need to change the exercise date and the payment date so that the exercise date is before the valuation date, which is the 24th of June 2021, and the payment date is after. So in this case here, we're just changing the exercise date and the payment date. In case 3b, we are also adding this automatic exercise node to, and we're setting it to true. Case 3c, we're setting it to false. And finally, here we are providing the underlying price at the expiry date at 4,200. So that's the stock price at this date. Just one thing about case 3b, we have to provide the fixing for this date in the fixing files, and you need to add EQ dash and then the underlying rig, and it's the same price as here. So now if we price it with ORE, and if we look at the NPV file, you can see that case 3a and 3c have 0 because we are assuming no automatic exercise of the option. Case 3b and 3d have the same price, and that's expected because we provided the same underlying price at the expiry date. And that is all I have in stock regarding how to configure an equity option as a trade. In the next video dedicated to the equity curve construction, we will be looking at the different types of curve configurations available in ORE, which one should be used depending on which market data is available, and we will do a deep dive into the algorithm used to calculate the equity forward at each expiry, which is not as straightforward as one may think when you have multiple quotes and the arbitrage-free property that needs to be respected. And we will start looking at the EQ curve tab, where the equity forward calculations and equity volatility calibration happens. And obviously the equity forward calculator has been replicated based on what's happening in the C++. Don't forget to like and to subscribe to know when this next video will be released. See you next time.